Okay, now we have a problem, which is not a problem. First of all, let me increase the number of points. Like this, maybe. Okay. We based our noise over the distortion attribute, but we don't have distortion on the newly created points on the circle. So we can say something like float distortion is equal to CHF distortion. And when we create the point, we can set the attribute distortion, new PT. Okay. So now we can decide how much distortion we want on the circle. Finally, we can extrude the shape in the Z direction. Maybe we can set 10 divisions, okay. And by the way, here we can put down a fuse node. Let me see. Yes. And a Boolean fracture. It is working. Okay. Okay, now we need to create a group for this central piece here. And for me, the easiest way to do that is to pack the geometry. Use a point triangle. And we can define, well, before that, use the second input for the impact point. Okay, we can grab the position of the impact point. Vector origin is equal to point 1p0. Okay, and then we can create an attribute. Let's call it dist. Is equal to the distance between myself and the origin. Okay, so if we take the minimum, we have the piece. Detail wrangle. Let's say float dist is equal to -1, and we have to save the index of the piece. So int point count is equal to n points of 0. Remember, we are dealing with pack geometry. For int I equals 0, I less than pcount I++. Let's grab the distance attribute, the float d is equal to point 0 dist I if dist is less than 0 or dist is no, let me think. D is less than dist. Dist is equal D. Index is equal y, I. So now we can set a point group 0. Let's call it impact zone. Index 1. Okay, let me check. Split. And that's correct. Okay. So before splitting, we have to unpack and transfer the group. Okay. Okay, now on this branch, which is the impact zone, we are going to Voronoi fracture the part. So we can merge and let's say Voronoi fracture, scatter some point, let's say 100 for now, without the relaxation. Okay, and the name is important because we don't want to override the old one. We want to append, let's say, dash. Okay, so the names, let me see the names. Okay, perfect. Okay, now we have to reset the impact zone group over the fracture geometry. So put down a group node here and set the impact zone over points. Almost done. We just need a RBD connected faces before packing, but let me say a few words about this node. It creates two attributes. Opposite face ID and prim dist. The opposite face ID attribute is based on the primitive ID, this number here. So for example, primitive ID 9 has an opposite face ID 30-40, and the distance between them is this one. Now, for some reason that I don't know, Houdini may change the primitives order during a simulation. And this is a problem because we are going to use the RBD disconnected faces later on after the simulation, which looks at this opposite face ID attribute. So if in the meantime the primitive ID is changed, it's not gonna work. For this reason, we have to store the primitive ID somewhere and restore it after the simulation. Let me show you a little scheme that I prepared to illustrate the point. So we save the primitive ID, we apply the RBD connected faces. We will use a DOP network to to simulate the bullet impact. Then we have to restore the primitive order before applying the RBD disconnected phases. This is the point. So put down a enumerate, let's say primitive underscore ID. You can call it whatever you want. And by the way, you can use enumerate, or you can use a primitive wrangle and say that, I don't know, primitive ID is equal to prim num is exactly the same. So this enumerate creates this primitive ID, which is equal to the index here. After that, we can pack the geometry. And what else? Okay, we need now to use the impact zone we have to transfer the group impact zone. Okay, and here we can say E at active is equal to 1. So the active pieces are only this one in the impact zone group. Okay, we are now ready to create the HDA, but let me clean up the tree a little bit. Radial lines, I forgot the prefix here. Lines. The sample is curve attrib, distortion attrib. Okay, this one is the circle. Circle, circle, circle. Extrude, noise, fuse, this one. Okay, assemble, attribute triangle. Okay, this one is find the central piece, the triangle. This is the impact zone group. Unpack, enumerate, let's say store primitive ID, and set active. Okay. Now we can create a subnetwork. Let's call it glass fractures. Okay, so create digital asset. Save to whatever you want. Let me remove this stuff. Glass fractures. Create. Okay. So we have two inputs and one output, parameters. Okay. So let's create a folder called radial lines. Lines count 1, line seed, uniform distribution, view distortion, the circle, circle level, and distortion. And maybe inside the circle tab we can put also the scatter, this one. Then the extrusion part. What is it? All extrude. This one. And the division. And finally, a noise tab with this one. Okay, now loss count, segment length, let's call it seed, uniform distribution, circle level, distortion, force total count, let's say Voronoi count, translate, this is depth, division, okay, apply. Okay,